Hello, welcome back to Nick Does Maths. Welcome minions. We've got some integration for you today. I thought I'd go through these because it's a small change, 1 over x squared minus 10x plus 34 and 1 over square root of x squared minus 10x plus 34, and we get very different results. Our goal here is to evaluate the integrals. We're told what sort of thing we're looking for in both cases, so that gives us a good guide. I'm aware there are standard results we can probably use, but the fun thing here is reminding ourselves where they come from to keep that adaptability going. So one thing I do know is what I want to do when I'm integrating something like this is I'm going to want to complete the square in the denominator. So let's start with that. I'll just do it once here and then we can see where we go from there. So x squared minus 10x plus 34 is x minus 5 squared plus 25, so plus 9. And what we're going to do is we're going to pull that 9 out to get 1 plus x minus 5 over 3 all squared. Now that's going to be really, really helpful for me for both of these integrals. So let's just bear that in mind. So, integral A. What does this actually become if I use this? This becomes 1/9 the integral between 5 and 8 of 1 over 1 plus x minus 5 over 3 all squared dx. Okie dokie. And again, you probably do have a standard result for this, but I'm going to go through it from scratch because I want to, and that is fine. U is equal to, just to make sure that we get all of our results fine, U is equal to x minus 5 over 3. Now, in fact, this is a 1 over 1. Yeah, we'll just go with this. So that tells me that du is dx over 3. So if we use that in there, we'll get 1/3. We lose one of the thirds to make up the du. If x is 5, u is 0. If x is 8, u is 1. du. And this I can just use the standard thing that I know. 1 over 1 plus u squared. That is 1/3 arctan of u between 0 and 1. So that will be 1/3. Arctan of 1 is pi over 4. Arctan of 0 is 0. So we end up with pi over 12. Jobs are good un for the first one. Right, B. Now we do need to be a little bit careful because this whole thing is square rooted. So we'll have to square root the 9. So what's 1/3 5 to 8? 1 over square root of 1 plus x minus 5 over 3 all squared dx. We're going to do a similar trick. We're going to change it from x's to u's in the same way as here. That 1/3 is going to combine with the dx to make our du. So that's 0 to 1, 1 over square root 1 plus u squared. Now, how do I deal with this? Now, you might have that as a standard result, fine, smashing, but let's have a little think what I might be able to use here. Now, I probably don't want to go for the tan approach. I possibly could. I'll get a 1 plus tan squared, which is sec squared. I end up having to integrate something to do with sec. I'm not feeling great about it. I won't lie to you. So what might I do instead? Now, there is a little key here, is that we're told we're looking for something as a ln. That tells me maybe hyperbolics. Now, we do know that cosh squared u minus sine squared u is equal to 1. So maybe if I rearrange that, cosh squared u is 1 plus sine squared u. That gives me a little hint. So what are we going to do? We are going to make the substitution. Let's do it over here. U is equal to sine u. Not u, we've already used u. What should we go for? V. dv is cos u du. I'll deal with that in a second. I don't... so, if u is 0, being a silly Billy, u is sine v. Much better. Du is cos v dv. There we go. This is going to do what we want. Now, if u is 0, we know sine of 0 is 0. And if u is 1, v is arc sine of 1. And we'll leave that as is for now. So what do we get? We get the integral from 0 to arc sine of 1 of 1 over square root of 1 plus sine squared, which is cos u, times I'll get there in the end, cos v times cos v dv, which is just the integral of 1. So that will give me v, evaluated at 0 and arc sine 1. So my answer is arc sine of 1. That's my answer. Now, that is not the answer they are looking for. We want something in terms of ln. But really, we just get arc sine 1. Whether you do it like full whack like I have done, or you just know how to do it from like lots of practice and standard, you just jump straight there, up to you. I'm not here to judge. But we do want that as a ln. So what is that telling me? If I'm saying that x is arc sine of 1, is telling me that sine x is 1. Let's use the math lifts to go down here. That is telling me that e to the x minus e to the minus x over 2 is 1. We can get that into... I'm not going to have room down here. So let's just fill this in here. So that's going to be pi over 12. And we'll get to this one. So let's rub out a. So I've actually got a bit of room. So we want to figure out what value of x has sine x is 1. E to the x minus e to the minus x over 2 is 1. That tells me that e to the x minus 2 minus e to the minus x is 0, bringing that up, tidying up. Which tells me that e to the x squared minus 2 e to the x minus 1 is 0. Multiplying everything by e to the x. And that gives me e to the x. Oh, do you know what? Minus 1 all squared minus 2 is 0. So e to the x is equal to 2 plus or minus, no, is equal to 1 plus or minus root 2. I can't have the minus because e to the x is always positive, so I can't have that. That tells me, where's my green gone? That we will get, taking lns of both sides, that is ln of 1 plus root 2. Nice. So a small tweak in the integral there, a small tweak. No square root and a square root. The type of substitution we do, the type of integral changes, and our solutions as well change very, very drastically, all by the presence of a square root. It's pretty cool. It's pretty cool. All of a sudden, without the square root, we can use a tan substitution. With a square root, it becomes much preferable to use a hyperbolic substitution. I don't know. I quite like it. I think it's pretty neat. Brilliant. I hope you found that interesting. Check out the link below. I'm Nick, losing my voice, and I will see you next time.